Okay, so let's do our last video of the year, organic chemistry test review. There's a few things on this review that we're actually not going to cover on the test, so I'll show you that as we get there. So yeah, let's just first start with geometry. So we have PCl5. We have 1 of these and 5 of these. So P will be in the middle, and the valence electron, 1, 2, 3, 4, 5. And then we have 5 chlorines. Seeing this, you should probably already be able to tell me what the molecular geometry is. There will be a bond here, 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 here. So technically it would be trigonal. The electron pair geometry is no different than the molecular geometry this time, and that's because there's no lone pairs on that center atom. So it's going to be trigonal bipyramidal, and same for this one as well. The only time the molecular geometry and electron pair geometry are going to be different is if there are extra lone pairs of electrons on that center atom. And with trigonal bipyramidal, it's not going to have any lone pairs. Hybridization for this one, we're actually not going to discuss on the test, but technically it's going to be an sp3d hybridization. And you can think of it the same way when we talked about hybridization of carbon. It has 5 groups that it's bonded to, and when you have 5 groups that it's bonded to, it says in the notes, if you've seen your notes and done it on your own, if it has 5 groups that it's bonded to, then it has this hybridization, and there's even more, but we're not going to go over that in this test or the review. BF3, you have boron, and that has 1, 2, 3 electrons, and fluorine has 7. So they're going to form bonds like this. Oops. Like that. It's actually not, this is new to you guys, it's actually not a pyramid because there's no electrons here. So this molecular geometry is going to be trigonal planar because it will be in that shape like this. Since there are no lone pairs of electrons, it's the same. Hybridization of this one, we can look. There's going to be 1, 2, 3 groups that boron's bonded to, so it will be sp2 hybridized. So if you'll remember, as just a review, when we talked about it, we have sp3, it's bonded to 4 groups. sp2 is bonded with 3 groups. sp hybridized is bonded with 2 groups. When you have sp3d, that's 5 groups. And you can actually go on, and it would be sp3d2, 6 groups. But this is in your notes. All right, so sp2 hybridized. CO2, you have carbon in the middle. This should be no problem for you guys to draw. This was new to you, so yeah, I understand if you're confused and weirded out by that. But here and this one, they should be pretty common. So this would be linear, and so would this one. And this carbon is bonded to 2 different groups, 1, 2. I do notice when you guys answer out loud in class that you kind of misunderstand groups for bonds. So make sure you don't see that, okay, that's 1, 2, 3, 4 bonds, so it's going to be sp3. That's not how you count groups. Groups is just something that it's bonded to. So this is 1, 2 things that it's bonded to. So that's sp hybridized. One I do want to mention that it's not on the review, but I know is on the test, is bent. So you have oxygen that's bonded to 2 things. It could be anything. I'm going to put R group because that could be anything. And so we have 2 oxygens bonded to something with its lone pairs of electrons. So the molecular geometry is bent. The electron pair is tetrahedral. I just don't think this was representative of the test, so I wanted to make sure I brought that up. Number 2, it says, what kinds of bonds make up the following molecule? For the same molecule, what is a hybridization on all of the carbon atoms? So guys, I'm not gonna lie, I'm literally gonna have a molecule the size of a page, and you're going to be telling me, answering these questions of hybridization of carbons, what kind of bonds do you see? So yeah, make sure you're like prepared to count a bunch of sigma bonds and tell me the hybridization of carbons. Let's just get started. So on the test, I'm not going to have you do every single one because it will be literally a whole page molecule. But I will have you recognize a certain type of hybridization of carbon. So keep in mind 1, 2, 3 bonds. So this carbon is actually showing 3 bonds. But in reality, there's another bond up here with hydrogen. So this is an sp2 hybridized carbon. Here we have 1, 2, 3, 4 bonds on this carbon here. So this carbon is only connected to 1, 2 things. There is no secret hydrogen. So it's going to be sp hybridized. This carbon has 3 hydrogens sticking off of it and another carbon. So it's bonded with 4 groups. So that's sp3 hybridized. As far as sigma and pi bonds, I am going to ask you to count sigma bonds and pi bonds. Honestly, I would like bring a highlighter, a couple of highlighters on the day of the test because it's going to get a little confusing, and I would draw like maybe sigma bonds with one color and pi bonds with another. I'm going to do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I do not see any other sigma bonds, sorry. So I'm going to say there are 20 sigma bonds on the molecule. Now with pi bonds, I would say there are 1, 2, 3, 4, 5 pi bonds. 5 pi bonds. Sorry if I miscount sigma bonds. Basically, you're counting every bond. So yeah, I think I got them all. So be prepared. You will have a big old molecule, and you're going to tell me sigma bonds, pi bonds, hybridization. Oh, geometries as well, which we're going over here. Okay, so here we're not going to be doing hybridization of other atoms other than carbon on this test. So skip this. You don't need to really be able to do that. Now, I need to confess to you guys one thing, a mistake that I have made. I'm going to accept both types of answers, that way for those kids who only listen in class. But for those of you who are like high achievers or trying to go to IB chemistry, I want you to know this before you go. The first day, I think it was 3rd block, I don't remember. It was one of those blocks where I taught it correctly and then a colleague corrected me. And so I changed the way it was taught. What I am talking about is the fact that dimethyl comes before ethyl. So what I've taught in class, the first day I taught it correctly, but any other day after that, I taught it incorrectly. I have said that it's a dimethyl comes before ethyl when actually you're looking at this. And that's what I said in the beginning, but I was corrected wrongly. So whatever block that I taught right the first time, and then I came and told you that I was wrong. Well, actually, I was right. And I was really wrong to listen to them, but whatever, that's my bad. So if you are going to IB, you're actually looking at here, the first one. So actually, ethyl would come before dimethyl if you're going to IB chemistry. Otherwise, this won't matter in your life, and I'm going to accept either way. That way, you know, I don't hurt the people who have already taught wrong. But just know this is actually the correct way. Moving on, so here, we're naming these molecules. So we have this group right here. This guy has like top priority in our 10th grade world, right? Our priorities are alcohol, amine, double, triple, single, or you may have seen me write substituent on the board, same thing. None of our substituents have double bonds, so that's kind of like a giveaway if you think like this is a substituent or something. Moving on, we have this alcohol, highest priority, so it needs to be the lowest number, period, no matter what is where. We need to identify our parent chain. Our parent chain is the longest continuous chain of carbon. So do not be trolled by things that you think are substituents when they're really part of the parent chain, only because they bend a certain way. Guys, these molecules are not stagnant. They bend, they move based on what's around them, not even just themselves. Themselves alone will cause it to bend and move. Molecules that just come near it can also have an effect on how it will bend and move. Parent chain. So we have 1, 2, 3, 4, 5, 6. So the parent chain is 6 carbons. And we're going to have to number 1, 2, 3, 4, 5, 6. The prefix is hex. Hexanol because of the alcohol. And it is located on the 2nd carbon. But we do have to deal with this. This is a methyl. and it's located on the third carbon. So 3-methyl, 2-hexanol. The substituents are only methyls. So parent chain, okay, longest continuous carbon is 1, 2, 3, 4, 5, 6, 7, 8. So that's 1, 2, 3, 4, 5, 6, 7, 8 carbons. And then we have 3 methyls sticking off of different carbons. So the parent chain is going to be called, since there are no double bonds, it's going to be called octane. Now we just need to indicate these trimethyls. So for sure, trimethyl. We started right to left numbering because that would give the first substituent the lowest number. Since there are no alcohols, we're okay with just dealing with just single bonds. So we have 3, 3, 4. Trimethyl octane. This right here should indicate that it is an amine. So naming amines are easy. The last part is always amine. And you just look at what's sticking off of it. So amine, there are ethyls actually. We have not discussed this in class, but there are ethyls. So you have 1, 2, 3. So it's triethyl amine. That's how you would call it. And then this nitrogen, since there are 3 carbons sticking off of it, it's a tertiary amine. Let's look at the parent chain of this one. So we notice a double bond, so that should indicate to you that the ending will be an -ine. So let's go over where we number this thing. So some kids would just want to call this the parent chain and they'd be wrong. That's because we need to find the longest continuous carbon chain. So we have, this is carbon. If we go this way, we only have 1 more carbon left, and that wouldn't be continuous, the longest continuous one. We still have 1, 2, a path where we can have 2 more. So we'll choose that. If you were to have chosen this one, that's fine too, it doesn't matter. So as far as numbering, we need to number from right to left because the double bond does take priority over the methyl groups. However, it doesn't really matter because you would have had to number from this way anyways, even if you were looking at only 6 substituents. So 1, 2, 3, 4, 5, 6, 7. So that 7 carbon chain means that it'll be heptene, E and E because of the double bond. Let's indicate where that double bond is. It starts. I saw on a lot of the quizzes where you guys started at like 3, but really it's 2. So it's 2 heptene, and now we have dimethyl. We have 2 methyl groups, 1 and 2. So dimethyl, second and third carbon. So dimethylamine, so remember amine is nitrogen, and we know nitrogen has 5 valence electrons. 2 will be a lone pair, and then the others will do whatever. So dimethyl means that there are 2 methyl groups sticking off of this. And then this one will be an H. So that's how you would draw that. You might also see it in H with 2 carbons. You could see it that way. It's still the same concept. Cyclobutene or butine, sorry. So bute means 4. Cyclo means it closes in on itself. This is a really odd example, but whatever. YNE means there's a 3 bond, and since it's cyclic compound, it doesn't really matter where you start the numbering in this case, so that would be it. Not that I can recall. You don't have something this crazy on your test. There might be an ENE, but just know that whatever this says, the ending indicates what type of bond it is. All right, 3-ethyl, 2-methyl, known and all. So we know that 9 carbon chain is the parent chain. 3-ethyl, so we'll just start with 1 over here. 1, 2, 3-ethyl, 2-methyl, known and all. So basically, if it doesn't indicate where that OL is, then you can assume that the OL is located on one of the ends. So you can assume that. But don't think that it's actually, hold on. This would not be, hold on. It would actually, because that is a carbon, if I write it there, it indicates that the oxygen, there's no carbon here. So let me make sure that this is clear. That is a carbon. So then here you would have OH, sorry. Then I also want to indicate that you cannot put the OH over here. That would be bad because that would mess up these numbers here. And if it was over here, that would mean that we broke the rule of putting the OH as the lowest carbon. It would be like, what, a 9 on the 9th carbon, and that's not okay. So if it's not indicated, you know it's on the 1st carbon. And this is a carbon, so don't do what I did and put the OH here. So number 8, you won't be doing this on the test. That's basically that crazy day we drew the animal balloon looking things. It's also in the 2nd video. So you can look that up if you want, like if you're interested in how to do this, but I'm not going to ask you to draw those types of orbitals or overlapping or anything, not this year. Remember guys, conjugated just means every other bond is a double bond. So this would be conjugated. Or we also saw it like that. That's conjugated. What's not conjugated is like that, or bad, or our weird butene thing we did. That's not conjugated. Okay, that's bad. Now, I guess if we did this, that's conjugated. That's okay. So conjugated just means every other bond is a double bond. All right, so naming class of compounds. So this is just functional group. So on the test, when it asks you to name the class of compound that the molecule is, it's just asking for a functional group. So this would be, it is cyclic and there's only single bonds. So this would be a cycloalkane. This has a double bond and nothing else, so this would be an alkene. You have just an O, oxygen, with R groups, okay? These are R groups, just like the rest of the molecule. There's no oxygen, there's no hydrogen, there's just the rest of the molecule. That's a ketone. To me, those are, ooh, I almost put my Y again. I always want to spell it like this. That's bad. Here, this is another easy one for me. I mean, I know y'all don't care about my opinion, but to me, this seems easy because it is very unique. It's a unique one. I think that these are a little more difficult to recognize, in my opinion. So this right here is an ether, and that one's easy. It doesn't have that oxygen double bond sticking off of it, so it's pretty obvious. Ketones are easy to me because there's nothing else down here, just carbons. Okay, now we have this and this. So ether and then ester. This is an ester. Ester looks like an ether and a ketone to me. Together. And then this, we dealt with this in lab. This is an aldehyde. And you really just need to practice recognizing these because honestly, it's memorization to me. And then there's isomers. You need to know what an isomer is if you are non-honors, but if you're honors, you need to be able to create isomers.